And welcome back. There's a certain day coming up. Do you know what it is? It's coming up. Whoa. Yeah, is this your date to the dance? Woo! Yeah. Starts with a J. Could have a K in there. You know, Jake or Jack. You left your ID badge. Woo! You left your ID badge. Who is it? Yeah. Coming up. So we're finishing up 7.4 right now. And so problem number 11 is what we're working on right now. Let's see, try it on your own. Try number 10 on your own. Get that negative 25 over, divide by negative 5. Number 11, give it a try. Try it on your own. So we're going to add 30 to this side. So then when we add 30 to this side, we get to 36. So we get 3 times 5 to the 2x plus 4 power. And then, what do we do? How do we get that 3 to the other side? Say it out loud if you know it. How do we get it to the other side, that 3? It's being times, so we divide by 3. So then we get 12. So 5 to the 2x plus 4 power now equals 12. So how do we undo base 5? Do you remember solving logs? How do you undo base 5? So we're going to undo base 5 by logging base 5. And if you do it on one side, you have to do it to the other side. Way-o. Because base 5 doesn't become 12. 12 is like 3 times 4. Not going to have the same bases on that one. Okay, so that cancels out. We're left with 2x plus 4 is equal to log base 5, 12. Put that 12 in parentheses so you don't mess up this next part, okay? So now we need to minus 4 to the other side like that. And then divide the whole thing. Divide, star. Divide the whole right side. Divide the whole right side by 2. So the whole thing by 2, so you're going to have to put this in parentheses to get the correct answer. Put that in parentheses. And now we're going to use our calculator. Use our calculator now, right? So we use our calculator, and we do parentheses. We do a math button, which is a log base. Option A, math option A. And so we have log base 5 of 12. Whoa. So log base 5 of 12, good. Minus 4, because we minus 4 to the other side. And then we divide it by 2. Then we divide it by 2. And so the whole thing divided by 2. So we get negative 1.228020345 to 4 decimal places is negative 1.2280. So we get x is equal to negative 1.2280 is our answer. Hey, Mr. Newbold, you haven't been plugging these back in. Oh yeah, should we try plugging it back in? Let's try plugging it back in to see if it works. So we're going to take that whole answer there, and why don't we store that in for x? Do you remember how to do that? So we're going to take our answer, second answer. We're going to store it in for x. So now whenever we type in x, we get that number. And now we're going to type in the original equation. So negative 30 plus 3 times 5 to the 2x power plus 4, close parenthesis, right arrow, close parenthesis. What should that equal if we did it right? It should be really close to this number on the right side. It should be really close to 6. So we're going to go ahead and plug that back in and see what we get. Boom! We got it. It works. So that one definitely works is our answer. And we plugged it back in using our calculator. Okay, so then try the next one on your own. You got this. Try the next one on your own. How do you undo log base 2? Right? What undoes log base 2? Well, if you base 2 both sides, right? If you shove a 2 underneath and raise you up down mountains, raise you up stormy seas, and there's You are the one. Oh, wrong song. Okay, so 2 to what power? We're going to raise you up to more than you can be. Go Josh Groban. What? So 2 to the log, so that's math butts in. So 2 to the log base 2 will cancel each other out. So whatever log is logging, we're going to have access to that. We're going to be able to grab that, which is this part right here. So yeah, so that's going to go ahead and grab that. Let's just say that's just some random number, I don't know, like, 692 when Columbus sailed the ocean blue. That's 1492. What are you talking about? And so that just gets you the number. And so the whole idea there, you guys, is that when you base 2 both sides, that gets rid of log base 2. So we're going to shove a 2 underneath there and shove a 2 underneath there. And that's going to get rid of log base 2. So now you have 2 to the 3x plus 2 power equals 2 to the 14. And now you can undo 2, right, by logging base 2. Again. So we're going to go ahead now and log base 2, and that's going to get rid of the base 2's. So now we have 3x plus 2 is equal to 14. We're going to minus 2 to the other side, so now we get 3x is equal to 12. How do we get that 3 to the other side? We're just going to divide by 3, So we get x is equal to 4, because 12 divided by 3 is 4, way-o. So if we plug a 4 in there and see if it works, we get log base 2. We get log base 2 of 2. Those could have just canceled out, Newbold. Oh, I forgot about that. Sorry. That's why we did the extra step. Sorry. Okay, so log base 2 undoes base 2. 2 to the 3 times 4 power plus 2 equals 14. Those cancel out. 3 times 4 is 12, and 12 plus 2 is 14. It works. So sorry for the extra steps. Sorry for the basing 2 both, but it was good to show you basing 2 both sides. Sorry for the extra step. Yeah, that was an extra step. Okay, there we go. Okay, try 14 now. Try 15 on your own. You got this. Try it on your own. So log base x of 625 equals 4. Couldn't we rewrite that as an exponential? I think we could. Could we not? I think we could. So we would do x to the 4 power equals 625. So x to the 4th power equals 625. And then we could guess and check. Guess and check. Guess and check. I'm going to guess that maybe 4 or 5 works. Maybe 4 or 5 works, maybe. Let's see. What do you think? Probably 5, huh? So let's try guess and check. So 4 to the 4th power is 256. 5 to the 4th power is 625. We found it. So that means that 5 to the 4th power works. And so we have 5 to the 4th power equals 625. And so 5 is our answer. And so x equals 5. It works. Nice. Oh, plus or minus. What the? 4th root? Both sides? Plus or minus 5? Does a negative 5 work? Huh. Let's give it a try. That's interesting. Never thought of that before. So then we're going to go ahead and do a math. And we're going to do log base of a negative 5? Really? Huh. Let's try it. So math log base of a negative 5 of 625. Yeah. I didn't think so. Yeah, that's an imaginary number. I don't think a solution negative 5. I don't think solution negative 5 works. So we'll mention that. I think to Lucarini, I think it's just a 5 that works, not a plus or minus. Yeah. So that's good to know. That's good to know. Okay, beautiful. Next page, just 5. Okay, so next is, let's see, try 16, 17, 18, 19. You got this. Okay, let's see here. So how do we undo the 2 first? It's like an onion. You got to work your way on the outside and peel your way into the inside, okay? It's like an onion. Let's go. Okay, so we're going to go ahead and how do we undo base 2? Well, that's not a base 2. That's a divide by 2. Oh, yeah. Okay. So divide by 2 to this side first. So that equals 4. Hey, what are you doing? Are you just copying me and writing it down? That's cheating. Don't cheat. And you're not going to learn. You're going to fail the test. So make sure that you try it on your own first. Push pause. Talk to the hand. I'm waiting. Pause me. Okay, so let's see here. So we get to log base 3 of x plus 4 plus 3 now because the 2's been divided over. Then we'll go to minus 3 to both sides next, working our way into the middle. So then that gives us log base 3 of x plus 4 to the 1 power. Because 4 minus 3 is 1. And then we'll go ahead and this is the part where I said you got to take a 3 and put it underneath it. So we're going to go ahead and raise you up, stand on mountains. I'll raise you up more than you can be. How can you be more than you can be? Okay, so beautiful. So log base 3 undoes base 3, so 3 to the first power. We get x plus 4 is equal to 3. And then we're going to go ahead and minus 4 to both sides. So we get x equals negative 1. So does negative 1 work? That's the question. Does negative 1 work? So we use our calculator to double check our answer now. So we go math, and we go log base. And so let's see. Oh, you forgot the 2, Newbold. Second insert a 2. So that was second delete, second insert. So that's a base 3. And then what do we have next? Whoa, that's on the outside, Newbold. You better use parentheses. Yeah, I better. So 2, parentheses, log base 3, x plus 4. What did we get for x? We got a negative 1 plus 4. And then next is our plus 3, close parenthesis. Well, did we get 8? We certainly did get 8. Well, we got 8. Woo! We did it. It works. We got 8. Nice. It works. It works. We got 8. Check. So x equals negative 1 is our solution for number 17. Keep on rocking. Keep on rolling. Number 19. Uh-oh, here it goes. Do you know how to condense? Do you know how to condense? You got to condense your logs before you can do this. So make sure that you condense first. Condense first. Condense first. Condense first. Okay, so we have subtraction. What does subtraction become? Do you remember? Do you remember? So log subtraction condenses to log division. Log division. Not long division, log division. Okay, so then log. So this condenses down to 1 log base 5. 1 log base 5 there. And then we have 45x first, so 45x. And then subtraction becomes division over, and then we bring down the 3 equals 1. So there we go. And so now how do we undo log base 5? So now we go ahead and raise you up, put a 5 underneath it, and raise you up. Okay, so then that gets rid of log base 5. So now we have 45x divided by 3 equals 5 to the first power, and 5 to the first power is just a 5. And then what's 45 divided by 3? Isn't that like 15x? Yeah, that's 15x equals 5. And then 15x equals 5, we're going to divide by 15. Whoa. And that reduces. Divide by 5, divide by 5. So you should get what, 1/3? X equals 1/3 for number 19. Yeah, 1/3. And plug it back in, it should work. It should work because 1/3 of 45 is 15. And then we have 5 to the 15 power minus 5 to whatever power equals 3, and it should equal 1. If you plug that back in, I don't have time. I gotta keep going. Okay, so make sure you plug them in. Whoa, condense first. So they're actually both log base 10. So don't forget that log x has an invisible 10 there. Yeah, log x is invisible. If there's no base, then we have an invisible base 10 there. Don't forget that part. Okay, let's see. So we're going to condense those down together to log base 10 of x plus 3 becomes x times x plus 3. Because log addition condenses to log multiplication. Log multiplication. Okay, so then we bring down this guy. Whoa, don't forget to remember the powers, properties of logs. The 2 goes up to the power. So then we bring it down. So we have log x plus 1 all squared equals that guy. And then we're going to go ahead, because the 2 moves up. And then this is technically log base 10. So now we can shove a 10 underneath both of them. And that gets rid of log base 10, rid of log base 10. So now we have x plus 1 all squared. This is a toughie. Equals x times x plus 3. Distribute. X squared plus 3x. And that's, how many x plus 1s do I have? I have 2 of them. Don't forget to distribute, FOIL it out. So x squared, x times 1x is just plus x. This times 1x is plus another 1x. And then 1 times 1 is just a 1. Okay, we want to get everything on the same side and maybe factor it. Oh no! The minus x squares to the other side are going to cancel. So those are both gone. This is a 1x. With the 1x is 2x. Plus 1 equals 3x on this side. We're going to keep our x's on the, keep them positive. Because during Valentine's Day, they will spread rumors about you, how you mistreated them and made them mad and negative. So keep your x's positive by minusing 2x to the other side. And when you minus that to the other side, 3x minus 2x is 1x. Equals, bring down the 1. Yeah, so x just equals 1. X equals 1. Wayo. Plug it back in, make sure it works. So if we plug a 1 in there, we get, let's try it. So that's 1 plus 1 is 2. So we get 2 log 1 plus 1, which is 2. And then equals, you see what that equals? That equals that number. On the right side, we have log where x equals 1, x equals 1. So on the right side, we get log base 10 of 1 plus log base 10 of 1 plus 3. And we should get the same answer. We do! So it works. It works. That is our answer. So then 23, last one. What about the back side? So the back side there is, there is an ACT question. Okay, so try 23 now. I'm going to try 23. So we need to condense. No, maybe. I don't know. Let's take a look. Interesting. So that's e to the 2x minus 4, e to the x equals 5. You can't really, well, I don't know. This is tricking me up here. Interesting. How would you even do that one? Number 23. I'm going to pause for a second because I am not sure. Oh, I remember now. So it's not a solving one anymore. Well, it is, but use your graphing calculator to solve each equation, right? Around the 4 decimal places. So we're going to have to plug this in on your calculator. Y1 equals e to the 2x minus 4e to the x power, right? And then y2 is going to be the other side. Y2 is going to be the right side, which is just 5. And then we're going to graph it and then we're going to use our calculator to help us. And we're going to graph them, and then we're going to go second trace. And so second trace is basically calc, and then it's going to be the intersection, right? What's the intersection? What option is the intersection? Extra credit, do you know what it is? It's option 5. Intersection is option 5. So again, what we do is we do second trace. So we do second trace or second calc is what we're going to do there. So here we go. We're going to do so second trace or second calc, in other words. And then we're going to do option 5 intersection. So let's do it. So you're going to go to y equals like that. You're going to plug in the equation. So we're going to go second e to the 2x power. Right arrow minus 4 times. There's going to be one of these on the test. You better watch out. You got to know how to graph some crazy functions, right? You got to know how to graph these crazy things. So that's one. That's the left side. Then we go down and type in the right side. And so wherever they intersect is the answer. So we're going to graph them. There we go. So I'm going to go zoom, and I'm going to go to zoom 6. To fix my window, zoom 6 is our 10 by 10 graph. Wow. So there's our intersection. Yeah, where is that? Okay, it's going to be a little tricky. Second calc. Where's the intersection? Okay, so it's going to ask for the first curve. You're just going to push enter. Now it's asking for the second curve. Enter. And then guessing, yeah, right where it is. Push enter. Enter 3 times. So enter. And we get the intersection where they equal each other at 5 is 1.6094. Right? 1.6094 is what we get there. Is our answer. That's our answer. That's the intersection. So where do they equal each other at? So they equal each other at x equals 1.609. 4 decimal places, 4. So there's our answer for number 23. That was crazy. That was just a very graphing one. Not so much solving, but very using your software. So then try number 24. You got this. And then 25. Ooh. So if that equals that is true, then what is A equal? Well, that's interesting. Let's see here. You could plug and chug because you have multiple choice answers, but maybe there's a mathematical way to do it. What do you think? So you have 3 radical 7, both on the top. That's interesting. But what makes the bottom different? Well, A radical 7 makes the bottom different. So how does that become a 7 is the real question. That's the real question. So let's see. That's a good question. Definitely not 1. That would definitely not help us. But maybe radical 7 times radical 7. What do you think? Should we try it? Let's try it. Let's try it. So what's radical 7 times radical 7? Well, radical 7 times radical 7 is radical 49. Because you can multiply them both underneath the radical. Oh, and the square root of 49 is 7. 7 equals 7. Woo! So I'm pretty sure that it's G. Yeah, it's G. Woo, that was kind of a guess and check. That was kind of a weird one. It's probably a weird way to do it, but I just kind of guessed and checked because that went faster than thinking how to do it. Woo! Nice. Thanks for watching. See you next time on 7.5. Thank you for watching. Happy Valentine's Day. Or not, if you don't celebrate it. Way-o. Woo! I choose you to be my Valentine. Watch for that lesson next. It's going to be funny. You'll see. Thanks for watching, and bye for now.